So one of the things that n-grams are good at is they're good at predicting what comes next, but that doesn't necessarily mean that they have much understanding of what the meaning of the words are or the code is. So how do we actually solve this meaning issue, or at least begin to take steps towards it? One way, sort of a traditional way to do this, is something called ontologies, where you will actually write down all of the relationships between the words and all of these sorts of things that let us know that, okay, there are 3 different types of bank that we talked about, right? All of this information. The problem with ontologies is that they're very difficult to create, and they're very hard to keep up to date once they have been created. One of the basic problems here is that when we go from the words that we say or the words that we write down to something that the computer can actually process, the way that we encode that is often as we've shown on the screen, where hotel will be a bunch of zeros and then it will have a 1 for the hotel column, right? And motel will be a bunch of zeros and have 1 for the motel column. And the computer, since it's only looking at those 2 differences of where the 1 is, it doesn't know that hotel and motel are actually very closely related to each other. They're just as dissimilar as hotel and motel and TV, or I guess TV is kind of similar. Maybe something like pencil, right? Those are words that aren't similar.
You can think of it as essentially any entry in any index, right? If I have an index of words, 2 words might be very similar, but they don't necessarily mean anything identical. It could be they're similar because they both fall under the same page,
right,
or they're both alphabetically organized,
right,
or for whatever reason, the 2 acronyms happen to look similar, but there's no semantic meaning that's actually connecting the 2 of them.
Thank you for that. I appreciate that. So how might you actually do this? How might you actually learn this? Before we go to that, I'd like to give an example of how we just intuitively know about how words work. There's this wonderful quote, you shall know a word by the company it keeps, right? Different words that are similar to each other are used in similar contexts. One of the techniques that we use for this is something called word-to-vec. And to be really specific, something like these 2 sentences, usually the large-scale factory is portrayed as a product of capitalism, is 1 sentence, and at the magnetron workshop in the old biscuit factory, Fisk sometimes wore a striped, right? And it's the words around the word factory that will represent the word factory. You will represent a word by its neighbors because that is a natural way to understand the meaning of a word, as opposed to try and come up with an index that is very specific, as we were talking about a minute ago. So go ahead. So how might you do that? Let's think, instead of words for a second, let's think about maps. So on the slide, what we have is we have Atlanta, Chicago, Denver, all of these different cities in the United States, and then we have their pairwise distances between them, right? So we know the neighbors very generally about each of these cities. Then there's a technique called multidimensional scaling that you can use that will then figure out where those cities are in relation to each other. And if you just look at that, you can see that we have a rough approximation of the shape of the United States just by looking at the pairwise distances of cities. So if you can know a city's location by the neighbors that it keeps, you can also know a word's meaning by the neighbors that it keeps. The way that word2vec does this is it in some sense makes a map of all of the different words that you have trained it on. So in this example, you can see that we have man and woman, uncle and aunt, king and queen. And the path to go from man to woman is the same as the path from uncle to aunt, and the same as the path from king to queen. It's the same, in some sense, compass bearing that you would take and then distance that you would travel. And when you have an encoding of the words that obeys those kinds of properties, you can do really interesting things. For example, you could say, okay, how do I pluralize a word? Well, let's go in the plural direction, from king to kings, or from queen to queens. Or we can even do more complicated things, like analogies such as king minus man plus woman would then equal queen. And it's these sorts of embeddings that have really moved the field of natural language processing forward. If you want to know more about how this works, there are a bunch of different sites where you can play around with these things. We have them listed for you. There's also a variety of other papers that have continued to move this direction beyond Word2Vec to other directions, such as taking into account not just the neighbors of the words in a sentence, but also, for example, its context in a paragraph, and models such as that. And we can also even do this for code, which we'll talk about in great detail a little bit later.
So before we actually jump off that topic, it's worth mentioning for those of you at home who are software engineers and know how to play with code. These tools, which you saw the links in the previous slide, they're actually publicly available. You can download toolboxes that enable this functionality, and they're very, very powerful. They can really, there are many tutorials online that'll teach you how to use these tools and techniques to directly build all sorts of chatbots, all sorts of textual analysis work, and similar stuff. And it's a very powerful technique that lets really anyone who understands how to use code and how to interact with these APIs, they can build some very powerful tools. So it's definitely worth checking out.